Hello, my dear Anna. Thank you very much for being attentive. And I'm your teacher, Saturday Enoch of Mathematics. Here to conclude our lesson 1 with example 3 under the same topic, a function and its derivative. Okay, now to work out this problem again, as you know and as usual, we shall first identify whether there is a presence of a function and its derivative. Remember, we are working out to the integral of sine cubed x cos x dx. And again, if I begin by letting maybe m equal to sine x, I want you to pay attention here that I'm considering sine x and not sine cubed x. Sine x and not sine cubed x. Why? Because I want to make the problem simpler and simpler. Okay. So if I let m equal sine x and I differentiate both sides, I observe that dm equals to cos x dx. When you differentiate sine, as you already know, you get a cos. Sine x, you get cos x. And of course, when you differentiate m with respect to m, you get dm. Now, when I reach this step, I will compare what I have got with the problem. I can see that the derivative of this is that again. And this one is derived from another part of the same problem. So, if this one is derived from this, and its derivative is very closely related to another part of the same problem, in such a way as you can see, then I conclude that in the problem there is a presence of a function and its derivative. Okay, my dear learner, after coming to that conclusion, we shall go on and work out the problem. And as usual, as I always tell you, let me begin by making dx the subject of the formula, where if I divide by cos x both sides, I will get dx equaling to dm over cos x. I get dx equaling to dm over cos x, as you can see the way I have done it there. If I divide both sides by cos x, then I will get dx equaling to dm over cos x, as you have seen. Okay, from there, I shall come back and consider the problem as a whole, so that my problem, which is the integral of sine cubed x cos x dx, is now equal to, by simple substitution, is m cubed, where m is sine x, times cos x, which is there in the problem, then again times dx, which is now dm over cos x. Okay, I repeat maybe. My problem, which is the integral of sine cubed x cos x dx, now is becoming the integral of m cubed cos x dm over cos x. Why? Because I changed the variable from x to m, where m is equal to sine x. So that sine cubed x is m cubed. Okay. My dear learner, we shall continue and work out this one algebraically, in which we shall have to divide cos x by cos x to get 1, or simply cancel cos with cos, cos x with cos x. Now our problem becomes the integral of m cubed dm, which by simple integration becomes m power 4 over 4. And when you reach here, it is meet that we express this final expression in terms of x, because x was introduced artificially, it was not in the problem. Okay, now it follows that the integral of sine cubed x cos x is cos x dx is equal to is now equal to m power 4 over 4, which I can write as 1 over 4 times m power 4, and m is sine x. So it becomes 1 over 4 times m, and m is sine x. Sine x. But then m is to power 4. So that if m is sine x, then m power 4 is sine power 4 x. And now I put power 4 there. Then of course, since we don't have the limits of integration, we shall add a constant, as you can see. My dear learner, this becomes the solution to the problem. In other words, the solution to the problem, integral of sine cubed x cos x dx is equal to a quarter sine power 4x plus c. Thank you, my dear learner, for being very good. Thank you, my dear learner, for being attentive. And I wish that everything goes well with you. And now I'm going to give you a simple activity, which I request you to practice, to pass through, so that when you contact me in your free time, we may discuss. It is only one item. It is only one item. It is only one item. Work out. Work out integral of cos squared 2x sin 2x dx. That is the problem. Work out integral of cos squared 2x sin x dx. Sin 2x dx. Maybe to remind you, my dear learner, I shall request you to consider 2x in a special way, which I believe you remember, and hoping that you have covered some problems under differentiation and integration that involve such cases. I fully trust that you will not be very much far from the right answer, but much my trust that you get the correct answer. May God bless you. You can feel free to contact me at redemption in Jesus Christ at gmail.com, or you can WhatsApp me at +2567066205070, or you can call +2567758756060, and then you give your comment, you suggest some issues, or even you get to understand some situations. I request you to work out this one, and then when we meet, we shall go on with lesson 2, in which we shall deal more and more with the problems involving trigonometric functions, like the example we have just done, and like the activity I have left with you. And when you contact me in your free time, we shall talk about that activity in a special way, and if the need is coming here to handle it together, then we shall do it. You can also pay for a wonderful hour lesson and receive it on WhatsApp, or by any means you feel accessible to you. May God bless you. Let us meet again. May God keep with you, blessing you forever until we meet in His kingdom.